This is our group member, Hakimi, Sharif, Faizullah, Muizzuddin, and Nick Adam. Now I will explain to you about our introduction. The Engineering Geology CPS project aims to provide students with hands-on experiment and a deeper understanding of geological features and processes. Through field observation and laboratory experiment, students explore various sites including the Air Hitam, Pantai Air Papan, Teluk Iskandar, and Cerong Batuang Pasir Lanun. The focus was on identifying mineral composition, analyzing sedimentary structure, and observing natural geological occurrences. Next, this is our objective for our project.
Okay, for the methodology, the first one is site investigation. We identify the rock types and structures using geological maps and field observations. Number one is classified weathering grade based on ISRM. Number two is observe geological features like faults, joints, and folds. Number three is conduct smidge hammer test to estimate surface hardness. Number four is collect rock samples to determine the RQD and discontinuity spacing. Number five is evaluated rock mass quality using RMR and JSI. Number six is measure discontinuities using Brunton compass and scanline survey. Number seven is analyze potential slope failures using sternoid kinematic analysis. And number eight is calculated the factor of safety for selected slopes. So next is the geological classification. So as we know, the rock types, we have three rock types, which is igneous, sedimentary, and also metamorphic. So weathering grades were observed visually and categorized from fresh to completely weathered, assessing surface condition, fractures, and textures change. Alright, so number three is the field test and measurement. So first one is smidge hammer test. We conduct on clean dry rock surface and we take at least 10 to 15 readings per site. And next is RQD and discontinuity spacing. And lastly is RMR and JSI assessment. So the last methodology is discontinuity and slope analysis. So the first one is Brunton compass and scanline surveys. We strike and dip of joints were measured, and scanline survey recorded spacing, aperture, infill, and roughness of discontinuities. So the second one is sternoid kinematic analysis. We plotted discontinuity and slope orientations, assessed potential for planar, wedge, and topping failure, and guided stabilizations recommendations. Number three is factor of safety. We calculate as FOS equals to resisting force over driving force. Values more than one stable and not more than one is unstable. So we compare against standard safety criteria.
Analysis and result for the site one, which is air hitam. First, types and formation of rock. The characteristic direct structure with fine grained particles and formed by accumulation, compaction, and cementation of minerals and organic matter. Next, weathering grades. Our study area mostly consists of grade 4 rock. And last one, geological structure. Our main deformation observed is faults and joints. Next is rock mass rating classification. So the first figure is joint set on slope. Next, Schmidt's ribbon hammer test and reading. And the third one is rock mass rating. So the item to calculate the rock mass rating is uni-axial compressive strength, rock quality designation, spacing of discontinuities, condition of discontinuities, and groundwater. So the total rock mass rating we got is 56, and our rock mass class is state, which is ferrock. The last one is discontinuities data collection. So this is our discontinuities raw data, poles of discontinuities, and planes of discontinuities.
Hi, I am Muhammad Sharif. I'll be explaining about what we get at Site 2 Teluk Iskandar. So first of all is the types and formation of rocks. So there are basically four types of rock which we found there, which is sandstone, phyllite, quartz, and quartzite. So most of the rocks are metasedimentary rocks with visible layers. So these rocks form from fine rock particles, which some with volcanic and limestone traces present. So phyllite is a rock that is shiny with fine layers and can be found between slate and schist. Meanwhile, quartz is a hard mineral that resists weathering. And lastly is quartzite, which is a tough rock from sandstone under heat and pressure. So moving up next is the weathering grade. So climates, which is like rain, humidity, and temperature, can affect weathering. So phyllite is one of the rock that weathers easily. Uh, in other ways, it is can weather chemically from clay to rusty look. So, and then for quartz, quartz is a very stable, which only breaks physically by abrasion and freeze throw. And lastly is the quartzite, which is also a rock that resistant but can crack under pressure. And lastly is the geological structure that we found at the site too. So basically we found three, which is folding, fault, and bedding. So folding is a rock bent by tectonic forces, and fault is a crack with sideways movement, straight, strike, slip type, and bedding planes is a layer in sedimentary rocks formed over time. Then, at site 2, we took reading for deep direction, deep angle, for bedding, folding, and fault. So, these are the values. Then, by these data, we get the poles of discontinuities and planes of discontinuities.
At Site 3 Cerun Batuan Pasilanon, we identified ignimbrite as the key rock. It formed when volcanic eruption blasts ash and pumice into the air, which rapidly cooled and solidified. Though classified as igneous, it shows a hybrid traits. First, sedimentary like layers from initial deposition and minor metamorphic changes from heat or pressure. This ignimbrite shows moderate weathering, evident from its brownish-yellow surface and brittle outer layers. It breaks under a hammer but resists handbraking, indicating partial strength retention. Crucially, its geological structure features irregular joints formed during cooling. These cracks like shattered the rock into blocks or acted as pathway for water or air and accelerated deterioration significantly. Okay, this is our rock mass rating classification RMR for our site 3, which is we get the total rock mass rating is 33, and we move to the rock mass class. Since our total rock mass rating is 33, under range 21 to 40, we classified the rock mass class is grade 4 for our site 3. Okay, this is our discontinuities data collection for our site 3. The left one is discontinuities raw data, and the middle one is poles of discontinuities, and the right one is plane of discontinuities.
Hello, my name is Muhammad Fazullah and I will continue to present about result and analysis Site 4 Pantai Air Papan. For the types and formation rocks, the rocks at Pantai Air Papan are mainly sedimentary, formed from a marine sediments that were compacted and cemented over millions of years. Coastal erosion and tectonic uplift have exposed this layer, which show features such as bedding plants and varying grain size that indicates different depositional environment. Some low-grade metamorphic rocks and minor igneous intrusion are also present, suggesting that the area has undergone past tectonic and geological activity. Next, for the weathering grades, rocks at Pantai Air Papan are slowly broken down by wave, wind, heat, sea spray, and humidity. They range from fresh grade 1 to very weathered grade 5. Rock at Site 4 are slightly weathered grade 2. The rocks are grey with black and white spots, showing small color change in cracks but still strong and hard. Weathering makes surface smoother and cause thin layer to peel off, with early sign of soil forming. Knowing the weathering level help us understand slope, safety, and coastal change. For the geological structure, tectonic faults at Pantai Papan have formed faults joined as small faults in the rock layers. This feature create weak spot where water can enter, causing faster weathering from wind and wave. Their direction match larger tectonic patterns in peninsular Malaysia. Studying this feature help us to understand past earthquake and how the land has changed over time. For the discontinuities data collection site 4, this is our discontinuity set and Sterenoid from the Clino app.
Okay, let's move to the discussion. Our team field analysis across Mersing Geopark uncovered 5 critical insights. Number 1 is rock type dictates risks. Shale at Aitam and Phyllite at Teluk Iskandar were the fastest, demanding immediate attention. Number 2 is weathering is our top enemy. At Aitam, grade 4 weathering turned rock to soil, which is slashing strength by 50%. Number 3, joints and faults control failure. Strike slip faults threaten which collapse at Aitam. Triple joint set at Pantai Air Papan risk catastrophic slips when wet. Number 4, RMR guide solution. Site 1, fair rock, needs bolts and shotcrete. Site 3, poor rating, steel studs and double strength shotcrete. Number 5, integrate field data, map joints, test weathering, and use RMR to predict prevent disasters.
For the conclusion part, in this study, we investigated for sites within the Mersing Geopark to understand rock types, geomechanical properties, and slope stability. Site 1 had a weathered sandstone and siltstone, while Site 2 showed meta-sedimentary rock linked to the Mersing granite suite. Site 3 featured ignimbrite, and Site 4 had sedimentary rock with signs of low-grade metamorphism. Using the rock mass rating system, Site 1 was classified as fair RMR 56 and Site 3 as poor RMR 33, each requiring different levels of slope support. Discontinuity and weathering analysis reveal complex geological features that affect stability. Overall, this fieldwork connected theory with practice and highlighted the need for detailed geological studies in engineering planning. Okay, that's all from us. Thank you.